Hey there, sixth graders, it's Miss Purrier. I am really sorry I couldn't be there with you today, but I am with you in voice and spirit. So we are going to jump into math today. We are going to step into solving one-step equations. Step into one-step equations, get it? I'm so funny. All right, anyway, we have had some exposure to this when we were working with proportions, and we did one-step equations with multiplying and dividing. We're going to get back to that or the next time I see you, I guess on Monday. However, today we're going to start with adding and subtracting. And so we have some basic things that we want to start by making sure we understand. So here's going to be this little vocabulary section we're going to get to go in. So an equation is a math sentence that does contain an equal sign. So that's the big difference between equations and expressions. Equations have equal signs, yes? The goal of solving an equation is to what we call isolate the variable. Now that means to get the variable by itself. Okay, so we know that the variable is equal to whatever we find as our answer. Now, the way we do this, right, is by isolating the variable on one side of the equation using, hopefully you remember, inverse operations. Okay, and so just a quick reminder of what that means. Yes, so the inverse of addition, yes, you should all be saying it out loud by now. Yes, subtraction, right, we're so smart, we know all of that already. And the inverse of subtraction is addition. You guys are so advanced, yay! And here's the key, and I guess if you were to highlight something or to make note, is this whole section right here, which is where advanced kids typically go astray, right? Because you know this stuff really quickly. So mathematically, you can figure this stuff out really quick and you don't want to show your work. But trust me, there is a reason why I'm having you show the work that I am, because later down in the line, you're going to have to know how to organize yourself. And so I'm just laying the foundation for that. So to keep the equation balanced, okay, because an equation is like a scale. One side is equal to the other side. So to keep it balanced, you must do the same operation to both sides of the equation. I'm going to show you what that looks like, and hopefully you can kind of remember from when we did that before. But I'm going to be really picky about this. So to save yourself some trouble, take more time to do it right the first time than having to go back and fix it later. All right, so let's look at these examples. Here we go. John has X dollars. If he adds $2.36 to his piggy bank, he will have $18.14. What is the value of X? So we've written an equation saying, okay, he had this much, and then he added this much, and so now he has a total of this. And so notice we were adding to X, so the inverse of addition is subtraction, okay, and then I'm doing it to both sides. Now, one of the steps you'll see here in just a moment on our next page is sometimes it helps kids to draw that line down the equal sign so they remember I have to do the operation to both sides of that line. If you don't want to do that, you don't have to, but sometimes it's just a helpful organization technique. And so we subtract both from both sides and then we get our final answer. It's always a good thing to go back and check. And so basically you just go plug in the value that you found and show your work. You don't have to show it in this way. For example, on this particular problem, I would expect you to actually line up your decimals because you don't have a calculator, right? And add them and show me that your answer is actually 1814. All right? All right, so this next one over here, let's go ahead and write our own. Maddie has X dollars. After spending $91.56 on a purse, she will have $45.98 left. What is the value of X? So we have X amount of dollars, and then she spends money, which means she's taking it away from what she had. So $91.56. And after she spends it, she has a total of $45.98. Yes? Okay, so then if we notice our operation currently, this number is being subtracted. So we're really looking for additive inverses here, right? So if we were to cover up that X you have a negative 91.56. So the additive inverse of a negative 91 would be a positive 91. And so I'm going to now add 91.56 to both sides. And again, line up your decimals so you know how to add your decimals correctly. And you end up with your 137.54. So then we would write that in a complete sentence. Maddie started, with 137, 54. Okay. And then to check that, right, we just go back, and then we would say 137.54 minus 91.56. So again, this is coming back to the original problem, just plugging in the x down here, and you would show me that that would be equal to 137.54. Or I'm sorry, that it would be equal to 45.98. All right, so that's kind of the basic, that's like the basic ideas. We're going to reiterate that here in the next page, but just to kind of give you an idea of where we're going and why we would use this, and this the process to do that. So go ahead and flip your paper over and we will continue our fun. Alrighty, so here we are at the adding, subtracting, one-step equations notes. Notice we do have just a couple more blanks to fill in. This is just to kind of reiterate those steps that you should be conscious of. So step one is start on the side with the variable, because sometimes it's on the right, sometimes it's on the left. And optional step two is to draw that line down the equal sign. If you don't need that organization piece, get used to not using it. But if you need it, please be consistent and use it. Then you're going to identify the inverse operation that's being done to the variable in order to isolate the variable. That's why step one is start with the side of the variable. You got to know what's happening with your x or your v or m or whatever the letter is. And then show the same operation on both sides. So you just want to make sure you're following those steps every single time. Now, I'm going to go ahead and draw the line the first couple times just so you can kind of see how that's helpful, but you do not have to continue doing that or do it at all, really. Okay, so first of all, the side of my equation with my variable is over here, so n minus 6, right? So I'm going to draw that line, and I'm going to start with doing the operation on the same side of the variable. So I notice that there is a negative 6. The additive inverse of negative 6 is positive 6. So I'm going to do that to both sides. And that line helps me make that judgment. And then that leaves me with n is equal to 8. Again, I know that you all can do that in your head. Oh, 8 minus 6 is 2. But we're really focusing here more on the process than the actual answers, okay? So bear with me. I know it might seem boring or mundane or unnecessary, but I promise there's a purpose. You just might not see it right away, all right? Thank you so much. All right, so then number 2, again, my variable's on the left. So we're going to draw that line down that equal sign. And now I know that it's 17 is positive. The additive inverse of 17 is negative 17. So I'm going to show that as a subtraction. And the whole reason we do that, right? Additive inverses, we know, add to 0. And we want that number to go away so that the variable can be left alone. Right? And so then we have a negative 10. Always go back and at least mentally check, right? So we would have negative 10 plus 17, 7. Oh, yep, that checks. Okay, that's all the process needs. All right, that's really all I'm going to do for you. I think you can handle that. Your substitute's going to be coming around and making sure that you're showing the work the right way. Obviously, answers are important to have those correct and be precise, but it's really making sure that you're showing the work. And so just think about, as I'm glancing down, right, number 8 here, again, we're looking for additive inverses more than inverse operations, more or less. So let me just do number 8 with you real quick since it caught my eye. The variable's on the left. If I draw this line here, now it looks like we're adding, well, we are adding a negative 3. And so if you want to do the inverse operation of that, that would be subtracting a negative 3. Yes? But we know, if we're just looking at additive inverses, the additive inverse to a negative 3 is a positive 3. We also know that a minus a negative is like a giant plus. And so adding 3 on both sides would be the same thing. So you can show it either way. So if you would like to show it as subtracting a -3 to be more consistent with that, and then knowing, oh, that's a giant plus, so I'm actually adding. Or you can just jump straight to, so if this was the problem, I'm totally fine if you just do +3. Okay, and you don't have to show the giant plus. As long as you understand whatever makes more sense for you, that would be the best option, right? As long as you have one of those 2 methods of work, I will be happy. All right, so I'm for real this time. I'm going to stop helping. You're going to work through the rest of this page. And again, it's less about the actual answers, more about the process that we're going to be looking for and checking. And then we'll get to an activity once everybody's done. Have a good weekend, guys, and I will see you on Monday.